Okay, so today we are doing lesson 4.5, Fundamental Theorem of Algebra. So we are still solving polynomials, but this time what's different about this lesson is that we are given no zeros. So in the last lesson, I gave you a polynomial, would give you one of the zeros, and then you would have to use synthetic division to find the others, okay? Well, here I'm not giving you any zeros, you're finding all of them yourself. So first example here, let's do f of x is equal to 2x cubed plus 4x squared minus 2x minus 4. And I want to know what x can be equal to. Well, number one, we need to notice that this polynomial is degree 3, which means I will have 3 solutions for x. So let's start just as a review by listing out our possible zeros. Okay, which remember are the factors of the constant divided by the factors of the leading coefficient. So here, my constant is -4, so that'd be plus or minus 1, plus or minus 4, and plus or minus 2. And then my leading coefficient is 2, and the factors of 2 would just be plus or minus 1, plus or minus 2. So my possible zeros here are plus or minus 1, plus or minus 2, and plus or minus 4, right? Because I would be doing 1 divided by 1, 4 divided by 1, 2 divided by 1, and then I would do 1 divided by 2. So I guess we have more than I thought, because we also have plus or minus 1/2, so I missed that one. And then 4 over 2, which is just 2, we already have right there, and then 2 over 2, which is just 1, so we already have that there. So there's our list of possible zeros. So what we could do is go ahead and set up our synthetic division. So this is degree 3, so x cubed, x squared, x to the first, x to the 0, put my coefficients under there. Okay, and then we could literally just do guess and check and start plugging numbers into this box. Start plugging these numbers into this box until we get a remainder of 0. Remember, we have to get a remainder of 0 here for it to be considered a 0. Another option that we have is to use our calculator to actually find the zeros on the calculator. And then we're just using synthetic division to show proof. So let's go to our calculators. So I have this scientific calculator app. This looks roughly like what your calculator looks like, but what I want to do is put this polynomial in my calculator. So I'm going to hit y equals. If there's something there, just clear it out. Oh, I have to hit y equals again. And then I'm going to type in the polynomial from example 1. So 2x to the power of 3 plus 4x squared minus 2x minus 4. So if we wanted to, we could hit this graph button in the top right and look, and you can kind of, it's harder to zoom in on your calculators, but we can kind of see, okay, I have a 0 here, here, and here, okay? So if you want to look at exactly where those zeros are, we can look at the table. So hit second and then graph. And then we can see our zeros. So we know this is a 0. We know it's an x-intercept if y is 0. So I have 3 zeros here, which makes sense. I have 3 solutions. So we actually already know what x is equal to. X is going to be equal to -2, -1, and +1. So let's go back to our notes here. So we already know, I don't want that anymore, that x is equal to -2, x is equal to 1, and x is equal to -1. But we're not totally off the hook because we have to prove our answers. So let's just plug in one of these numbers in this box and start doing synthetic division. Let's plug in -2. So drop down the 2. -2 times 2 is -4, 0, 0, -2, +4, and a remainder of 0. Okay? So that proves that x is equal to -2. From here, I can rewrite this as a quadratic. So this is x to the 0, x to the first, and x squared. So as a quadratic, this would look like 2x squared plus 0x, so I don't need to write that, and then -2. From here, we can factor to find our other answers. So I know I'm going to get an answer of +1 and -1. So let's start by taking out the GCF, factoring out a 2, and then I have x squared minus 1, and then this is a difference of squares problem. So 2 times x plus 1 times x minus 1. And this is where we get x is equal to -1 and x is equal to +1. So here I can see your three answers, 1, 2, and then 3 right there, okay? So even though your calculator tells you these solutions, I still need to see all of this work on your homework and on your test, okay? So let's do this again. Let's do another example here. Let's do f of x is equal to 2x cubed minus 5x squared minus x plus 6, okay? So this is degree 3, so I know I'm going to get 3 answers for x. Okay. Let's just think about our possible zeros for a second. So possible zeros are factors of the constant, which is 6. So plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3, divided by the factors of my leading coefficient, which is 2. So plus or minus 1, plus or minus 2. So if I were to write all of these out, it would be plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3, and plus or minus 1/2, plus or minus 3, which we already did, plus or minus 1, which we already did, and then plus or minus 3/2. Okay, so this time we have some fraction options as well, which I guess we did on the first example as well. Let's go ahead and set up synthetic division, and then we're going to use our calculator again to actually see where our zeros are. So x cubed, x squared, x to the first, x to the 0, 2, -5, -1, and 6. Draw our little box. Okay, so let's go back to our calculator. Plug this in. 2x cubed minus 5x squared minus x plus 6. We can look at the graph and we see, okay, I have 3 x-intercepts, which makes sense. I should get 3 answers for x. Now let's look at our table to see where they are. Okay, so I see 1 0 right here at -1, and I see another one here at 2. But if we look, we don't see any more zeros for y. And the reason that is because our third solution for x must be a fraction. So if you notice this x column here, these are all whole numbers, -2, -1, 0, 1, 2, 3. They don't go by fractions. So sometimes if we look back at the graph, we obviously see there are 3 zeros, but one of these, and it must be this one right here, is going to be a fraction, okay? So the ones that we clearly see from our table, the answers that we clearly see, are that x is equal to -1 and x is equal to 2. We really only need one to get us started here. So let's go back to our notes. So I know 2 of my answers are that x is equal to -1 and x is equal to +2. We still have to find the third one, and we're going to have to find that by factoring. So let's just plug in one of these answers for x and use synthetic division. I'm going to plug in -1. You could plug in -2. It doesn't matter. Drop down to 2, -2, +7, -6. Okay, so this worked out the way we wanted it to. This is 0. And now let's write our quadratic. So this is 2x squared minus 7x plus 6. So to factor this is a guess and check problem, starting with 2x and x. And how this would factor is 2x minus 3 and x minus 2. So this factor right here clearly tells us that x is equal to 2. That's how we got this answer up here. But then this one, we need to set equal to 0 and solve for x. So my fraction answer is that x is equal to 3/2. So that's what we could see on our graph, but not necessarily see on our table. So sometimes that happens, so you can't always see all of them. Okay, let's do another. Let's do f of x is equal to 2x to the 4th plus x cubed minus x squared minus x minus 1. Okay, so here the degree of this polynomial is 4, so that means we're going to have 4 solutions for x. My possible zeros. Also, I want us to be clear, and we'll see at the end of this problem, the possible zeros are possible x-intercepts, not necessarily all possible solutions for x. So hopefully you guys kind of notice the difference there. Zeros are x-intercepts, but what we're really doing today, we're not only finding x-intercepts, we are finding all solutions for x. So my possible zeros here are factors of the constant, which would just be plus or minus 1, divided by factors of the leading coefficient, which would be plus or minus 1, plus or minus 2. So my possible zeros here, possible x-intercepts, would be 1, plus or minus 1, and plus or minus 1/2. Okay, so let's set up our synthetic division. Okay, and then again, let's type this into our calculator to see some of our zeros. So let's look at our graph. Okay, so here we notice that this only crosses the x-axis 2 times, but we have 4 solutions for x. So that must mean that 2 of our solutions are going to be imaginary. Let's look at our table to find the 2 real solutions for x. So second table. So it looks like my 2 real solutions for x here are -1 and +1. Okay, so let's just let's plug in one of these solutions for x. Let's do -1. And we get 0 as a remainder. But if you notice here, this would not be a quadratic anymore. This would be a cubic, because it would go x to the 0, x to the first, x squared, x cubed. Well, since we have another solution for x, we have x is equal to +1, let's just do synthetic division again on these numbers. So that way we have it down to a quadratic. So we already know we should get a remainder of 0 here. And we did. Okay, now let's write this as a quadratic because now we can solve for x. So this is 2x squared plus x plus 1. Well, this trinomial is not factorable. We can't do anything. So this would be an example where to finish solving for x, we need to use the quadratic formula, which we kind of talked about how these last two solutions are going to be imaginary. So that should give you a clue, hey, we're going to have to use the quadratic formula here. So a is 2, b is 1, c is 1. And then we can just simplify. -8 divided by 4. Okay, now we need to simplify the square root of -8. So we're going to have to pull out an I. Plus or minus I root 8 divided by 4. But we still need to simplify the square root of 8. And that would simplify to 2I root 2 divided by 4. That's as simple as it goes. And wait, did I do something? I did something wrong here. I'm so sorry. I was looking at the wrong problem. We will do this for the next one, but I did some math wrong here, didn't I? This should just be a -7. So then all we would have to do here is pull out an I. So -1 plus or minus I root 7 divided by 4. Okay, sorry about that. So these would be our last two solutions because remember that plus or minus makes it 2 solutions. So my last 2 solutions for x are x is equal to -1 plus or minus I root 7 divided by 4. So on our graph, when we used our calculator, we saw these 2 solutions for x as our zeros, but we didn't see these solutions because these solutions are not zeros. They are solutions, but they're not x-intercepts because this is an imaginary number. Okay, let's do another similar one. Okay, so here, this is degree 5. Okay, so we know we're going to get 5 solutions for x. Okay, so we are going to plug this into our calculator to see if we have, some real solutions for x, find out where our zeros are. So let's plug this in. And then we can look at the graph. Okay, so here we notice that one of my x-intercepts, it crosses through. And then I also see only one more x-intercept. Here, it's hard to see, but this one right here at 1, see how it bounces? So we talked about this in class, but if it bounces, that means it has an even multiplicity. So that means x is equal to 1. I get that answer multiple times. We don't necessarily know how many. It could be 2, it could be 4, but it's just an even multiplicity. But we know that at least 2 of my solutions are x is equal to -2 and x is equal to +1. Again, we don't know how many times x is equal to +1, but we know it's at least going to be twice, right? It could be more, but it's at least going to be twice. So those are at least 3 of our solutions. One, at least, let's make it like a little note here. We don't know this yet, how many, but at least twice. Okay. Could be 4. Again, could be 4, could be 2. Can't be 6 because we only have 5 solutions, but it could be 2, could be 4. So let's set up our synthetic division. Okay, this one we are going to have a placeholder because I don't have an x cubed term. And then let's just plug in -2 in for x. Okay, and we want to continue doing this because I don't want to try to solve for x because this would be an x to the 4th problem, right? So let's keep going. Let's plug in 1 and use synthetic division. Okay, and I know that 1 is going to be an answer at least another time, so let's just plug in 1 again. And then from here, we could do guess and check and plug in 1 again, or let's just go ahead and write this as a quadratic and solve the way we know how to. Okay, so this one, I think, would this be factorable? Could we do x? No, this is not factorable. I thought for a second that it is, but it's actually not. So we need to use the quadratic formula. So that tells me my other 2 solutions are going to be imaginary because we didn't see them on the graph. So this answer of x is equal to 1 definitely has a multiplicity of just 2. Okay, so right now we have 1, 2, 3 answers, and then when we use the quadratic formula, we're going to get our other 2 answers that are going to be imaginary. And I know that they're going to be imaginary because we did not see those x-intercepts on our graph. Okay, so let's simplify this, hopefully correctly this time. 2 plus or minus the square root of -8 divided by 2. So I'm just going to skip ahead and simplify the square root of 8. So this would be 2 plus or minus 2i root 2 divided by 2. Well, remember, since I have a 2 here and a 2 here, I could factor out a 2 on the outside, and then these 2's would cancel out. So again, this is very quick, but our final answer here would be x is equal to 1 plus or minus I root 2. Okay, because when we cancel out all of these 2's, that's what I would be left with. Okay, so again, here's our answers: 1, 2, 3, 4, 5. All of our 5 answers there. Okay, now we're going to do 2 more examples, but we're going to switch it up a little bit, where here we are going to write the polynomial function given the zeros. Okay, so these are kind of going backwards. Okay, so for example 1, I'm going to tell you that x is equal to -2, x is equal to -4, and x is equal to -7, okay? So let's think about how we get our solutions for x. Normally, if they're nice, clean numbers like this, they come from factors, okay? So basically, I'm gonna have 3 factors because I have 3 solutions for x, okay? And to get this answer right here of x is equal to -2, that means I'm plugging in -2 for x, but I have to put a number here to make this factor equal to 0. So this factor would be x plus 2. Because think about it, if we have a factor like this, normally I ask you, what number would we plug in for x to make this factor 0? Well, we would plug in -2, okay? So likewise, this one, when x is -4, the factor we would have to get x is equal to -4 would be x plus 4. And then this last one, -7, we would have to get the factor x plus 7, okay? But this is not a polynomial function yet, so this is very tedious, but we need to multiply all 3 of these binomials together. What I always do is I start with the first, well, actually, let's start with the last 2. I think it's going to be a little bit easier. It doesn't matter, but let's just start by multiplying the last 2 binomials together. So this is FOILing. So we still have this x plus 2 out in front, but then when we multiply x plus 4 times x plus 7, we get x squared plus 7x plus 4x plus 28, okay? And then I can combine these like terms in the middle. Okay, and now I have a binomial times a trinomial. So now I'm going to take the x, distribute it to every term here. So that's x cubed plus 11x squared plus 28x. Okay, so I'm done with that one. And then I'm taking the 2 and doing the same thing, multiplying it to all of these terms. Okay, and then the last thing I'm doing here is just combining like terms. So I start with x cubed, and then I combine my x squared terms, and then my x terms, and then I have this plus 56 here at the end. So I'm going to put an f of x out here, and then this would be my final answer. Okay, so that would be the polynomial that has these 3 zeros. We could put this into our calculator and show that it has all 3 of these zeros. Okay, we won't do that, but we could. Okay, let's do one more example here. So let's say I have x is equal to 5 and x is equal to 3i. Okay, so let's think about our factors here. So to get x is equal to 5, obviously that would just be x minus 5. Okay, but then keep in mind, so this is kind of a trick question, because if I have an imaginary number, that means I would have had to use the quadratic formula, right? And what are we missing here? If we use the quadratic formula, we always get how many answers? 2, right? So really, if I know that I have positive 3i, I should also recognize, hey, I am also going to have negative 3i. So this is actually 2 factors from just one solution. So I should get x plus 3i and x minus 3i, okay? Which normally we don't see it written like that because we would have to use our quadratic formula. But here, since we're given the zeros, it kind of makes it a little bit easier. So let's start by just multiplying these two binomials together. So I still have the x minus 5 out front, but here this becomes x squared minus 3ix plus 3ix minus 9I squared. Okay, so this is kind of ugly, but recognize that these two in the middle just cancel out to 0. And then negative 9I squared is really negative 9 times negative 1, because I squared is negative 1. So really this is x plus 5 times x squared, and that would be plus 9. Okay, and then from here, this is just two binomials, so we're going to FOIL multiply these together. Okay, and then I just want to rewrite this in standard form where my exponents are descending. So final answer here is going to be f of x is equal to x cubed minus 5x squared plus 9x minus 45. And that's our final answer.